Hello everybody, welcome back. This is my second class on number system. In the first class, we discussed about the different terms related to the number system. In this class, we are going to learn the representation of rational numbers on number line. Now before we do that, let's just look at some fractions. Now if we see some fractions, say for example half, what do we exactly mean by half? Say in maths, one whole thing is represented by number 1. Now if I need half, what do? I break it in the middle. So this will be half of the whole thing. Remember, whole thing is 1 in maths, or it can be 100%. Anyway, since we're doing fractions, 1 will be whole thing, and if you need half, we have to break it from the middle. So if I represent this point as 0, so this much will be half, and the whole thing will be 1. Now let's look at another number, say 1 by 3. Say I have a piece, say maybe a piece of chocolate. I need to get 1/3 out of it. What do I mean by 1/3? 1/3 would mean I have to break this into 3 parts, and each part, this 1 part, 2 parts, 3 parts. We have broken it into 3 parts. Each part, this 1 part, will be 1/3 of the whole. The whole is 1, remember. This much if I take, it will be 2/3 out of, because we are taking 1, 2, 2/3 of the whole. So if I represent this point with 0, this will be 1/3. This will be 2/3. And this till here will be the whole thing, so it will be 1. Okay. Now let's represent some fractions on the number line. The first one is 3 by 5. Okay, 3 by 5. What we'll do is, the first one, 3 by 5. Here you can see 3 is smaller than 5. The numerator is smaller than the denominator. So in that case, we know this number is going to lie between 0 and 1. So on the number line, we'll draw a line. On this line, we'll just write 0 somewhere, and then at a certain distance, say this much, we'll take it as 1, equal distance 2, and so on. Okay, then this side you can write -1, -2, and so on. Now what is important, that this number is going to lie between 0 and 1. So, and see the denominator. The denominator is 5. So what we'll do is, between 0 and 1, we will try to divide it into 5 equal parts. 5 equal parts. So 1 part till here, 2, 3, 4, 5. So let's see, 1, 2, 3, 4, 5. So 5 equal parts. Make it equal. Then the first point, that first point will be 1 by 5. This will be 1 by 5. This will be 2 by 5. This point will be 3 by 5. If we go to the next point, it will be 4 by 5. So we are looking for 3 by 5. This point, we can just extend it and write 3 by 5. So this point, you can denote it by some letters. So you can write also A represents 3 by 5 on the number line. Now if we look at the next question, 4 by 7. Let's make another line for that, for number 2. 4 by 7. Again, it's going to lie between 0 and 1 because the numerator is smaller than the denominator. So we will draw a line. Somewhere we can represent 0 here. Now since we have to divide into 7 equal parts, let's divide it first and then we'll write 1. So here the denominator is 7, so we're going to have 7 divisions. Here we had, the denominator was 5, so we had 5 divisions. 1 division, 2 division, 3 division, 4 division, 5 division. So here we have to have 7. So this is the first one, the second, third, fourth, fifth, sixth. And the 7th division, this one will extend a little bit and we'll write 1. Okay, and then the first number will be, this will be 1 by 7. This will be 2 by 7. This will be 3 by 7. This will be 4 by 7. This will be 5 by 7. This will be 6 by 7. And that 7 by 7 is 1. So we want 1, 2, 3, 4. This one. So we can just put an arrow and write 4 by 7. So we have representing. So we can also write some letter, say B represents 4 by 7 on the number line. So remember, this whole thing, it's representing, here it's 0, the whole thing is 1. So you can, if you want same equal distances, you can write 2 somewhere, and the side this much distance you take -1 and it will go on. So you just put an arrow marking. Now let's look at the third question, 25 by 6. Now 25 by 6, this number in the numerator is greater than the denominator. So we have to convert it into mixed fraction. So 6 into 4 is 24. 6 4s are 24. 25 minus 24, 1 left. 1 by 6. So 25 by 6 can be written as 4 1 by 6. You can divide it and check. 6 into 4 is 24. The remainder is 1. So 4 will write here 1 by 6. Now, how do we represent this? Again, now since it is 4 here, we know this number is greater than 4. It will lie between 4 and the next number is 5. So let's write first 4. Somewhere we'll write 4. Okay. And then the denominator is 6. So the denominator is 6. So we want 6 divisions. So we can just write 1, 2, 3, 4, 5, then 6th one. This will be 5. Okay, from 4 to 5. It will lie between this number is going to lie between 4 and 5. That's why I've started directly from 4. So this is 4 and that's 5. And this point here in between, this will be 4, 1 by 6. This will be 4, 2 by 6. This will be 4, 3 by 6. This will be 4, 5 by 6. 4, 6 by 6. Like 5 by 6, this one. So in this point, the first one, this point is going to represent 4. 4, there's 4. And this first point, so it's 1 by, since we have divided 6 part, 1, 2, 3, 4, 5, 6. So 4, 1 by 6. This point is going to 4, 2 by 6. Since we need 4, 1 by 6. So this is the point, say we can write letter C represents. Now, if you want, you can just to extend the line at equal distances. So if it is 4, 5, so at this much distance, you can write 6 and put an arrow mark. Take one this side also, same distance. This will be 3. So this point is representing 3. You can have 2, 1, 0 and all those. Instead of writing all, you can just put an arrow mark. Okay, so number 25 by 6 is lying between 4 and 5. And this point is representing 4, 1 by 6. Now similarly, number 4, it's a negative number. So negative will come to the left side. Let's see. Let's take this number minus 15 by 4. If we divide this, 15 by 4, 4 into 3 is 12, remainder will be 3. So this is going to become this 3, and 3 by 4. So since minus, we'll put a minus sign. Now how do we represent this minus number? Now this number minus 3, and since it is negative, the next number after minus 3 will be minus 4 on the left hand side. So this number is going to lie between minus 3 and minus 4. So let's start from somewhere here. Say this number is minus 3. So we're coming this side. So how many divisions we need here? The denominator is 4. So we need 4 divisions. So let's count the division first. 1, 2, 3, 4th. The 4th one will extend. 1, 2, 3. The 4th one will extend. And we'll write the next number minus 4. So I want minus 3, 3 by 4. This will start counting from this side. Minus 3. This will be minus 3, 1 by 4. This will be minus 3, 2 by 4. This will be minus 3, 3 by 4. We want minus 3, 3 by 4. So this point is minus 3, 3 by 4. So we can just write this. We can denote it by some letter, any alphabet, say P represents minus 3, 3 by 4 on the number line. Now at this much distance, same distance, we can just to extend the line, you can have minus 2 here, and you can go on, and this side will be minus 5 at equal distance. You can write minus 5, minus 6 and so on. Okay, let's look at the next question. Find a rational number between minus 2 and 6. Now, if you draw the number line, so we have 0 here. Then this side minus 1, minus 2. You go this way. 1, 2, 3, 4, 5, 6. Now I've written these two numbers, minus 2 here and 6 here. Now you can see there are many numbers in between. These are the integers in between. In fact, we have infinite numbers of numbers in between these two. So if you take only the integers, we have minus 1, 0, 1, 2. So if we have to write only one rational number between minus 2 and 6. So we can write a rational number between minus 2 and 6 is, you can choose any one from here. You can write 0, you can write 1, you can write 2. Let me write 1. So you can write any other number. But if the question was find a rational number exactly in the middle of minus 2 and 6, exactly in the middle. So if the question was exactly in the middle, then the answer would have been, what we'll do is we will take this minus 2 and we will add with the last number. Minus 2 and 6 will add and we'll divide by 2. We'll get the number which is exactly in the middle. So here 6 minus 2 makes 4. 4 by 2. 4 by 2 will be 2. So this 2 will be exactly in the middle of minus 2 and 6. But the question is not, you have to write any rational number between minus 2 and 6. So you can write any one of them. But if the question was to find a number exactly in the middle, then we will do it this way. Now let's look at the next question. Here 0.75 and 1.2. We have to write one of them. So 0.75 and we have 1.2 here. So in between these two. So we have 0.76, after 75, 76, 0.77. In this way it will go on, we will reach 0.80 or 8. Then you will go on, then you will reach 1, then 1.1, 1.2. All these numbers will be there. So we can choose any one you like and write a rational number between these two. And you can write any one of them, say this one or any number you like. Okay. Now coming to this type of question. If this type of question where you have to find a rational number between 1 by 4 and 1 by 3. Supposing I'll write here a rational number between 1 by 4 and 1 by 3. Now here we can do it different ways. If you have to find only one, the best method would be just add these two numbers and divide it by 2. Divide by 2. Add and divide by 2, you will get one number in between. So in order to add, we will take the LCM. LCM of 4 and 3 will be 12. 4 3s are 12. So 1 3 is a 3 plus 3 4s are 12. 1 into 4 will be 4. Divide by 2. So 7 by 12 we are getting here. Into, we'll change this division into multiplication. So this number will become reciprocal. 2 by 1 will become 1 by 2. So if we multiply now, we will get 7 by 24. So a rational number between 1 by 4 and 1 by 3 can be 7 by 24. Okay. Similarly, you can do this also. You can just add this 2 and divide it by 2. You will get a rational number between these two. Moving to the next question. Find 5 rational numbers between 1 by 4 and 1 by 3. Now, previously we did 1. Now we have to find 5. Now, in order to find more than 1, then the best method would be like this. You take the two numbers. The first one is 1 by 4 and the second one is 1 by 3. You take the LCM of the denominators in order to make the denominators same. So the LCM of 4 and 3 is 12. So let's make it 12 here. In order to make it 12, 4 into how much is 12? 4 into 3 is 12. So we'll multiply with 3 here as well. So this will become 3 by 12. Similarly, this 1 by 3 will make the denominator 12. 3 into 4. Here we'll multiply into 4. This will become 4 by 12. Now, we will check these two numbers. We don't have any integers between 3 and 4. But in order to find 5 or more, so what we'll do is we multiply both numerator and denominator with 10. Here also we will do the same. We'll multiply. If you multiply by 10 there, we'll multiply by 10 here. So up and down, both numerator and denominator. So the number becomes 30 by 120. Now here it will be 40 by 120. Now we check these two numbers. Now we have between 30 and 40, we have 31, we have 32, 33, 34, till 39. So we have more than 5, so it will be enough. Supposing we want 16, 17, then instead of multiplying by 10, we can go 100 also, we can use 100 or any number you like. So just to make the number bigger. So, okay, so now since we have to find only 5, so we can just write like this: 5 rational numbers between 1 by 4 and 1 by 3 are, what are the numbers? You can write any number you like. 31 by 120. You have to keep this denominator. Then the second 32 by 120. You can make it into its lowest term or leave it like that. Then 33 by 120, 34 by 120, 35 by 120. In the same way, we can do this number. So we have minus 3 by 4 and minus 2 by 5. Now, the first step, what we do is we will take the LCM of 4 and 5. 4 and 5 will be 20. So, to make it 20 here, we'll multiply by 5. Here also we'll multiply by 5. So, it will be minus 15 by 20. In this case, we have minus 2 by 5. In order to make it 20, 5 into 4. So, here we'll multiply with 4 to make it 20. In the denominator, we are multiplying with 4, so this will be minus 8. Now what we'll do is, we'll first look at these two numbers. If we get what we want, then we will not multiply by 10. So between minus 8 and minus 15. So minus 8 is here, then comes minus 9, minus 10, minus 11, minus 12, minus 13, minus 14. Then comes minus 15. So we already have more than 5. We have more than 5 here. So we don't need to multiply with 10. We'll just directly write 5 rational numbers between this and this are, any one, you can write minus 9 by 20, then minus 10 by 20, minus 11 by 20, minus 12 by 20, then minus 13 by 20, or you can choose any from them. So we have 1, 2, 3, 4, 5. Okay, now let's look at the third one. We have 2.1 and 2.2. Now between 2.1 and 2.2, let's see. What we will do is, 1 and 2, we don't have any numbers. So you can just increase the decimal places. Here you can just add a 0. It is 2.10, and here also we'll increase by 1 place. Same number of places. Then between 10 and 20, we have many numbers. So we want 5 of them. We can write 10, 2.11, 2.12, 2.13, 2.14, 2.15. Enough. If you want more, so you can increase another place here also. Then you can have as many as you like. There are infinite numbers of rational numbers between these two numbers. So if similarly these two numbers, this number 3 and 4, we have 3 and 4. So what you can do is, it's like 3.0 and this is like 4.0. So we can write the numbers in between are 3.1, 3.2, 3.3, 3.4, 3.5, 3.6. Similarly, you can write as many as we like. But in the book, you may have seen they are applying a formula like this, denoting one of them by x equals to 3, y equals to 4, and then calculating. And since we need to find 5 of them, n equals to 5, then applying the formula d equals to y minus x by n plus 1, getting d. This is just a waste of time when we can do it in a very simple way. Why apply formula? In maths, we should not apply any formula if you can do it directly. Maths formulas are meant only to make calculations simple, not complicated. So I would suggest don't use such formulas which makes things more complicated instead of making it simple. Let's take another question. Here, find two irrational numbers. Before the previous time, we did rational. Now let's look at the numbers. We have 3 and 4. Now, if you remember, irrational numbers are those numbers which has non-terminating, non-repeating decimals. So we can do it like this. With 3, we can write 3.01, 001, 0001 and continue. This will be one number, and you can take 3.02, 002, 0002, and so on. This is one way you can go on. You can write as many. This, see, it's not repeating. The pattern is same. It is following a certain pattern, but the repetition, it's not same. It's not 3.01, 3.01. Had it been 3.01, 01, 01, then it will be non-terminating repeating decimal, which will be rational. This type is irrational. Non-terminating, non-repeating. The same number is not repeating. So we can write this too, or we can do another way. We can write 3 as root over 9. We know 3 is root 9 is 3. Square root of 9 is 3. Then 4 we can write it as root 16. Root 9 is 3, which will be rational. Root 16 is 4, which will be rational. But I want two irrationals between them. So we can write between 9 and 16. Now we have many numbers. Between 9 we have, after 9 we have 10, root 10. We can write root 11. These are all irrational numbers. Root 12. These are irrationals. So we can go on. We need only 2. So similarly, you can do the next one. Here, 0.1. We can write it as 0.10 first, and 0.2. You can write 0.20, making the increasing the places of decimals. So now you can just increase from 10. You can go to 11. Say 0.11, and then write something else. Say 01, 001, 002, or 001. Sorry, 03 zeros we can write, and so on, and we can get as many as we like. Now coming to the next question, here, without actual division, find which of the following rationals, all these are rational numbers, has terminating decimal. So now we have to tell without dividing whether this has terminating decimal or non-terminating repeating decimal. As we already know, 6 points to remember. A rational number can have either terminating decimal, means a decimal which stops, it does not continue, say after 0.15 or any number, it stops. Or non-terminating repeating decimal. Say if you take a rational number 1 by 3, when you divide, you will see that it comes out 0.3333. It will continue. So this type is called non-terminating repeating decimal, or also called recurring, and we put a bar for representing this. Anyway, so how will I know without dividing which one will, whether this will have terminating or non-terminating decimal? So in order to do that, we have to remember this very, very important point. If the prime factorization of the denominator, remember the denominator contains only 2 and 5, then the rational number will have terminating decimal. That means if we have a rational number, we'll check only the denominator. If this denominator, say if it is 25, so we'll have only 5 and 5. So if it has only 5 or only 2, supposing it's here 8, denominator is 8, we have 2 into 2 into 2, then it will be terminating. Or you can have both 2 and 5. Supposing you have a number which has denominator 2 and 5, it will be terminating. So if you have only 2 and 5, or only 2 or only 5, then it will be terminating. But if it has any other prime numbers like 3 or 7 or any other prime number, leaving out 2 and 5, if you have any other prime number, then it will be non-terminating repeating decimal. Okay, now let's see whether 5 by 12 has terminating or not. So what we'll do is, we'll check the denominator. What is the denominator here? Denominator is 12. Now if you prime factorize 12, if you break like this, 2, 6, 12. Use only prime numbers, 2, 3 is 6. So we can write it as 2 square into 3. Now you can see we have another prime number 3. We should have only 2 and 5 in order to have terminating decimal. So we will write like this. Since the denominator has prime factor 3 other than 2 and 5. Remember, it should not have any other prime number other than 2 and 5, but it has here. So therefore, this 5 by 12 will have non-terminating repeating decimal. And what does it mean? It means if you divide this, the decimal will not stop, but it will start repeating after certain places. Now number 2, 21 by 80. Now 80, if we break, we can write it to 40, to 20, to 10, to 5. So the denominator, which is 80, we can write it as 2 to the power of 4 into 5. Now what do you see here? We have only 2's and 5's. We don't have any other prime factors. So we'll write, since the denominator has only the prime factor 2 and 5, has only the prime factors 2 and 5. No other prime factors there. You can write, since the denominator has no other prime factor other than 2 and 5. Therefore, 21 by 80. This number 21 by 80 will have terminating decimal. Has terminating decimal. So, if we look at the next one, we have 16. 16, if you break, it will come as 3 by 2 to the power 4. And if it has only 2, if it has only 2, this will also be terminating. So this will be terminating. But if you look at this one, we have 15. 15, you may think it's 3 into 5. But you have to be careful. When you look at this type of sums, you have to be very careful. Before checking the denominator, you should be able to see this. See, you can cancel this. 3 1s are 3, 3 5s are 15. So we are left out only with 5 in the denominator now. We are left only with 5. So this number 3 by 15 will have terminating decimal, because I told you already, this all should be in the lowest terms. These numbers were already in the lowest term, but this was not in the lowest term. So first step, be careful, cancel if possible. After cancelling, then only check the denominator. Here the denominator after cancelling. Before cancelling, we have 3 into 5. You may think it will have non-terminating. Before cancelling, we have 3 into 5. 15 is 3 into 5. You may think it's not terminating, but actually it's terminating, because we have to convert it into the lowest term. Next question, express as decimal 5 by 8. So we just have to divide 5 by 8. So since 8 zeros are 0, then 5, give a decimal. So 8 6 are 48, then 2. Since we have already placed a decimal, so with 0 will come. 8 2s are 16, and 4, and the 0 we can bring. 8 5s are 40. Now we can divide and get the answer straight away. Or there's another way, if it is terminating decimal. So we can see it's 8 2 cubed. Without dividing, we can also get it. So if you want to do it, you can do this way also. You can learn this. We have 8 as 2 cubed. It will have terminating decimal. This we can follow only for terminating decimal. So we will make equal numbers of 2's and 5's. How many 2's do we have here? 3 2's. So we will put 5's also in the denominator, same numbers of 5's. So if you multiply anything in the denominator, we will multiply in the numerator as well. Okay? And then we will get, if you multiply this 5 into 5 into 5, 125 into 5 is 625. Divided by this 10 cube. These 2 5's are 10. So 10 cube. That means 10 cube, there are 1000. It will become. Now, without dividing, since we have 3 zeros, 1, 2, 3, you can write 0.625. The decimal will come like this, 3 zeros. So 1, 2, 3. We'll put the decimal here. There are 4 zeros. Supposing there were 4 zeros, so 0, we'll put another 0 in front of 6 and then put the decimal. Now similarly, you can divide. If you can either do by dividing, we're getting this, or if you want to follow this, and this can be done only for terminating decimals. This is also terminating. This also can be done this way. Say this will be 7 by 25. 25 we can write 5 square. I've got 5 square. So since we have 5 here, we can put 2 square. Here also we can write 2 square. So this will come as 7 into 4, 28. So 28, and there will be 10 square. 5 2s are 10 square. Or the same, 10 square means 100. So 28 by 100, 0.28. See, without dividing also we can get the answer. Now if it has non-terminating, here this is non-terminating. Looking at the denominator, we know it will be non-terminating repeating decimal. So for non-terminating repeating decimal, we cannot do this way. We have to divide and get it. So we'll just divide 8 by 3. Here 8 is divided by 3. 3 2s are 6. 2 is that remainder. You put a point. 0 will come. 3 6 are 18. Again 2 will come. Say again 6 will come. So in this way, this 6 will keep on repeating. So we can just write this as 2.6 bar. 6 is repeating. Let's look on some very important objective questions based on whatever we have learned so far. First one, is 0 a rational number? This is a very common question. 0 is a rational number because we know 0, we can write it as 0 by 1. So we have integer by integer. So this is, yes, it is a rational number. You have integer by integer. Are all real numbers rational? No. Why not? Because we know real numbers, under real numbers, we have rational as well as irrational. So all real numbers are not rationals. All rationals are real, but all reals are not rational. Some reals are irrational also. Okay. In the same way, some questions supposing if you get under rationals, we have the integers. Under integers, we have the whole numbers and the natural numbers. So if you are asked, are all whole numbers natural? Every whole number is a natural. No, every whole number is not a natural. Why? 0 is a whole number. 0 is a whole number, but it's not natural. Every natural number is a whole number, but every whole number is not a natural number. See, whole number includes 0, and 0 is not a natural number. So it is false. Now, next question, the decimal form of irrational numbers. So we have learned decimal form of irrational numbers is always non-terminating and non-repeating. Non-terminating, non-repeating. Let's look at number 5 now. If P by Q is a rational number having terminating decimal, then the prime factorization of Q, now Q remember is the denominator, should be in the form. Now we know if it has terminating decimal, the denominator, Q is denominator, should have only 2's and 5's. So in the form of 2 to the power m into 5 to the power m. This m and n are whole numbers. This m and n are whole numbers. It can be any numbers starting from 0, 1, 2, 3. Okay. If you look at question number 6, which of the following are rational numbers? We have to select which one is rational and which one is irrational. Okay. Here 1.2. 1.2 is terminating decimal. It stops. So it has to be rational number. So this is rational. Now this one 0.01, 01, 01 just repeating. So we can write it 0.01 bar. So non-terminating but repeating. This one also we know it is rational. So this is rational. If we come to the next one, 0.01, 001, 01, then 001, 0001. So this is new. Same number is not repeating. 01 like this one, same number is repeating. So this it's non-terminating, non-repeating decimal. So this is irrational numbers. So I'll write IR, irrational numbers. Okay, if we come to this number, pi by 2. If we have pi, remember, any number containing pi, it will be irrational numbers. So IR, irrational numbers. Now if you look at this one, root over 4, root over 4 will become 2. Root over 81, 9 9s 81, so it will become 9. So this is a rational number. So this is rational number. Now if I come to this number, let me write it down right on top, 0.4. Now if you write 0.4 as 0.2, this will be wrong. Why? See, if you make it into fraction, it is 4 by 10. 4 by 10, if you cancel, it will be 2 by 5. So it's root 2 by root 5. We cannot remove the root here. So this number is actually irrational. So 0.4 is irrational. But if I take the next one, if I take this one, 0.04, 0.04, then it will be, answer will be 0.2. I can show you how it will be 0.2. Let's say 4, this is 4, after decimal 2 places, 1, 2, so 4 by 100. 4 by 100 makes root over 4 is 2, root over 100 is 10, that will be 0.2. So this is a rational number. Okay, that's all in this class. In the next class, we will be learning how to convert terminating decimals and non-terminating decimals into fractions, and we will take a little bit on the simplifications of irrational numbers. Okay then, bye and see you in the next video.